is on. Okay, here it goes. So once again, good morning to everyone and welcome to week 11 lecturing classes. Today is no more quiz. I mean to say, like, there is no quiz for today's session. So hopefully you guys are more relaxed, it seems. But anyway, we have a very important topic today. We are going to have like more or advanced understanding of hypothesis testing, where we'll see more than two or like the most of the cases where we'll see the two different population, and then we will try to see is the claim is justified or not justified, accepted or not accepted. So those kind of thing we will do it. The hypothesis testing we will do it with the more than two population. Especially we will see that two different cases, which is very important. One is independent data, and the second one is dependent data. I mean to say the two different samples could be dependent or could be independent. So we'll see that one comparing the means of the two independent population, whereas in the dependent data we will compare the means of the two related population. I mean to say related population. I mean the sample 1 and sample 2 will be somehow related. We'll see through the examples, various examples, how what the possibilities, how could they will be related to each other. Maybe at the last we'll see the proportion. The hypothesis testing is for the proportion. Okay, it depends on the time, but we'll try to have that one with one example. That will be at the end. So remember, we are talking about the sample now. So sample statistics. So we are in inferential statistics, right? No more in descriptive analytics statistics. So inferential statistics involve forming conclusion or making an inferences about a population parameter based on the sample statistics. So sample statistics, we are trying to extrapolate, we are trying to make a reference for the population parameter like mu and sigma, where we have seen the sample statistics are x bar, p hat, or the capital S, that is the standard deviation for the sample. So you know, I'm assuming that all these notations are in your mind. So maybe in the exam, the kind of tip is like maybe it will be given capital S. So you have to think about this is like for a standard deviation for the sample. So sometimes you need to be very careful with the notation. You need to, because we have not changed the notation, whatever we have, like we were consistent throughout the classes with the notation for the specific term. So keep that one in mind. So the two major activities of the inferential statistics which we were trying to cover in this syllabus is, the first one is inference and the confidence interval estimation. And the second one is testing the claim about the population parameters. So in this syllabus, we have covered two different aspects of the inferential statistics. And today again, we are trying to have advanced level of testing the claims about the more than two population parameters. So as I said, you have like either more than two population or the two population which could be dependent or independent. For example, test the claim that a mean body temperature of a males is different from the mean body temperature of females. What do you think? Is it a independent sample, independent population I'm talking about, or these two populations, these two samples are dependent? So think about that one. Okay, you'll see that, but there could be like this sort of example to understand the dependent and independent. So we have a various examples which will give you more clarity in terms of when it will be dependent or when it will be independent. So talking about the two means or the independent samples, keep in mind, okay, anyway, we will be talking about independent samples and the independent samples through the various examples. So what is important here, we'll discuss the situation when the population standard deviation is unknown. I mean, sigma, population standard deviation sigma is unknown. So in that case, you know that we have to apply the t statistics. We have seen in the single population mean, when the sigma was like unknown, the population standard deviation was unknown, we were simply applying the t statistics. So that keep that in mind. We need to calculate some t stats, and then accordingly the p values, and then the decision making regarding the p value less than the significance level or greater than, and then either you reject or not reject the null hypothesis. So probably you have the mindset like how we proceed the 7 steps testing the claim in the single population. We will try to do the same, like we will try to follow the same 7 steps when we will consider the two different population, or maybe the dependent population or samples, or the dependent or independent samples. So we'll try to do the same exercise today. So take an example of like few examples of like the independent samples. When you think that two samples are independent, I mean, if one sample is for the males and one sample is for the females, do you think this is an independent sample or dependent sample? Of course, this is an independent sample. So the two samples are independent if the sample values from one population are not related to or somehow naturally paired or matched with the sample values from the other population. So for example, males and female populations, they are the independent samples. Think about in the healthcare industry, we have a control groups and the treatment groups. Even, you know, the Queensland University nowadays, they are trying to find out the new vaccines for the coronavirus. So what continuously they are doing, they are keeping one group as a treatment group and one as a control group, and they are trying to see the consequences. You know, is there any improvement in the corona patient who has given the treatment in compared to those who are in the control group. So clearly that is an independent sample. One is a control group and one is a treatment group. So there could be various parameters on which you can select, or on which you can decide it is an independent sample or dependent sample. Here it goes. It's a very good example, very good example, and this will give you the complete view or holistic view in understanding the when it will be dependent and when it will be independent samples. So we are talking about the experimental study, and we know that the different types of studies. One is survey, one is this is the third type, experimental study. So what we do in the experimental study, mostly we have a population and we take the sample in order to generalize something for the population, right? So these samples are random samples. So it's a randomization. I mean to say, like, you need to take the sample as at random. So once you took the sample, what you did, you divided into two different groups. One is the experimental group and one is a control group. The control group, you are not going to have, you're not going to treat them especially in terms of maybe providing new drugs or maybe giving more capsule sort of examination or capsule sort of training or something like that. Is the control group. You are not going to provide them something extra. Whereas in the experimental group, you are going to treat those samples members by providing new sort of treatment or new sort of vaccination or new sort of training, a new sort of whatever. So that is the experiment or the treatment group. So, and then what you do, you will collect. The moment you have two different groups, experimental group and the control group, what you try to do, you try to collect the first data collection before for the experimental group and first data collection before for the control group. I mean to say, like, before any treatment, you took the data in terms of their body temperature, in terms of their BMI, or in terms of their performance before any training program. So you're taking the first data collection before the experiment for both the groups separately. Then what you did, as I said, for the experimental group, you provided the treatment, special treatment, whereas for the control group, you could see there is no treatment. And after that, maybe after 1 week or after 1 month or after 1 year, based on your research setting, what you did, you again took the collection, you again took you gathered the data, and that is known as the second data collection. That is after, for the experimental group and for the same for the control group. So start thinking about, if I'm talking about the independent group, do you think these two are experimental group and the control groups are the independent group? Yes, they are like they are independent in a sense, like there is no match. in between in these two sample of people or sample members. So they are the independent groups. We'll talk about when it could be a kind of dependent group. So considering this experiment as independent groups, two different groups, one is experimental group and one is control group. What are the comparison we can do? I mean, what kind of claim, what kind of testing we can perform? So you could see the testing at the same level. Maybe one testing could be trying to understand, is there any difference is there any difference in means between experimental group and control group before the treatment? That could be one claim. I mean, say, can you justify, can you frame some questions based on this experimental setting? What kind of claim could be possible? Like, either you can have a kind of claim, or maybe is there any like, is there any difference in the mean between these two group of people after the treatment? So that could be one comparison, or that could be one claim, whereas another one will be before the experiment. So is there any difference between the mean value of experimental group and control group before the treatment? That is the one. The question could be based on this sort of claim. We wanted to see, is there any difference at the significant level, 5% or something? Or there could be another one, like, is there any difference between the experimental group, the difference between the means? Keep in mind, difference between the means of experimental group and control group after the treatment, based on the second data collection. So that could be another sort of claim which you wanted to, as a researcher, you are interested in testing. So these sort of thing you will cover in today's session. I mean to say, you have more than one population. Before that, we were doing everything with the single population. We were given a single population mean, and we were trying to justify or prove some sort of claim that mean value was greater than 368 grams, lower than 68 grams, or it's different from the mean value. So it's a single population. But over here, we have two different population. One is for the experimental group, one is for the control group. And then I'm just trying to see what kind of claim is possible, what sort of claiming could be made in terms of framing the questions. So there could be two different types of question framing. One is like, is there any differences in the mean for the experimental group or the control group before the treatment? And the second claim could be, is there any difference between the mean of experimental group and the control group after the treatment? So these two cases are there where we will treat this experimental study as a independent sample. But in the same frame, there is a possibility to have a kind of dependent sample that we will discuss in the second phase. But over here, just now try to understand from the point of independent sample, and two different sort of claim is possible, or framing. The question could be framed. Any doubt? I mean, is it coming? I hope. Okay, let's go ahead with that one. Probably with the more examples, it will be clear. Okay. So considering the experimental studies, just now we outlined in the previous slide. So we have randomly allocated two subjects to two different groups. So one subject or one group is control group, no treatment. Placebo group, I mean, there is nothing special. It's a like normal dose of medicine. Placebo is a term used in the healthcare industry. To have placebo means normal doses of the medicine. Whereas the experimental group, where you are trying to give them something special, maybe the coronavirus vaccine, they are giving they are trialing, they are making the trial of those vaccine with the treatment group or experimental group. And we take the measurement from both the subjects before and after the treatment. So there could be several comparisons. As I said, we can compare the scores between the two groups. And we can compare these scores both before and after the treatment. So that's what I was telling, two possibilities there, before and after the treatment. But in this case, we are treating this experimental setting as a independent group. There is no kind of correlation between the treatment group and the regular group. Over here, so clearly it is horizontally, you see the direction, like one level of comparison and second level of comparison in the red circle. So one sample of one claim could be, is there any difference in mean between experimental group and control group before the treatment? That is in the blue circle. Whereas the second level of comparison could be, is there any difference between the mean values of experimental group and a control group after the treatment? So consider in the previous, in the single population, we were just dealing with single mu, right? Mu naught. But over here, two samples. So we have mu1 and mu2. So while framing the null hypothesis, is there any claim? I mean to say mu1 equal to mu2, that will be the null hypothesis. Or an alternative hypothesis could be mu1 not equal to mu2. We'll see with the example. So keep just trying to give you some like little bit inputs. Maybe later on in the next slide will be covered nicely. So the comparing the result between the two different groups. So keeping in mind, we are considering two different groups over here, control group and experimental group or the treatment group. The same further explanation, so nothing new in this slide. We hope the randomization process has worked and the both groups are similar before the treatment is given. I mean, it's a kind of randomization process. There is no chances of biasness. So both groups has been taken at the random sample using the randomization. So that means that is the meaning over here. So we can carry out hypothesis test to check this. Is there any difference in the mean? I mean the mu1 for the sample 1 and mu2 for the sample 2. Is there any difference in the mean? I mean the mu1 equal to mu2 for the null hypothesis. Alternative will be, is there any difference? So mu1 not equal to mu2. So something like that on those lines, we'll see that one. We can carry out the hypothesis. Okay, this is a very good example. Just take your own time to understand the case. Very, very important. Very, very important. We'll try to solve this one. So what is given here? A gym is trying to determine whether introducing a new sort of program like boot camp program is effective or not in helping their members to lose their BMI index. And what is BMI index? No need to understand theoretically or analytically. Keep in mind, something is like trying to improve the body, some sort of measurement that makes people healthy. So they were trying to see the effectiveness of some program, the boot camp program. So what they did, randomization, 20 randomly selected members. A club or gym could have more than 1,000 members. So the randomly they have selected 20, and they have given some sort of kind of motive why they will participate. So these participants will receive a free membership for the week. That's why they thought to participate. Without any motivation, nowadays it's difficult to get the respondent. So 20 randomly selected members of the gym agreed to participate in a trial. So they would be required to participate in this training each morning for a week. The participants were randomly allocated to two groups. So 20 random samples, right? So 10 and 10. So what they did, the 20 participants who has shown the interest, they have divided into two different groups. One is the boot camp group and the second one is regular group. So boot camp is your treatment group. Just now I was talking about. And the regular group is your, what is that? The regular group is your control group. You're not giving anything. It's a control group. So regular group is control group, whereas boot camp group is your treatment group, experimental group. The BMI were measured at the beginning of the trial and at the first week of the trial. I mean to say before the training, after the training, before the trial, after the trial. So this is an experimental study because of the participants were randomly allocated to the two different groups, and these are the variables of interest. So what are the different variables of interest? One is the group, two different type of training. One is boot camp and the second one is regular. And then the BMI before the trial and after the trial. So the BMI values are the numerical value. You will get something in the numeric, whereas the type of training is boot camp or regular. B or R is a kind of, we know that categorical variable, especially the nominal one. So let's see here. This is the one I was talking about. So what are the variable of interest? As I said, the group, either boot camp or regular, B or R. BMI before and BMI after. How many participants are there? 20. Out of 20, two different groups of equal participants. So 10 are in the boot camp, those having given the this sort of training program at the gym, and whereas the another 10 from K to T, they are the guys who has not received any special treatment. So they are in the control group. And then what we did, the gym manager did, they measure the BMI before start at the beginning of the program or the first day of the week, and then after 1 week they have taken another measure of BMI, and that is the BMI after. So for the participant A, suppose the group A, group boot camp participant subject name is suppose A. We are just trying to make sure that the person name should not come in the experiment, so we are just given the some sort of dummy name. So A to J for the boot camp members, whereas the K to T is the for the regular one. And you see there is a like BMI before 25.2 and BMI after 23.1. And so there is a difference in the BMI 2.1 for the first member. Like the same way you have done it for the all 20 participants. Now in the right side in the image you could see what they are trying to show. You know the box plot. Keep that one in mind. Box plot, it gives a kind of mean, median, and the differences inter quartile 1, quartile 2, and quartile 3. So you could see the 5-point summary, if you could remember. So we have the minimum, and the top we have the maximum, and then you have quartile 1, quartile 2, and quartile 3. Quartile 2 is always a kind of mode. So there's a sort of comparison here. Is there any difference between the BMI before in these two groups, boot camp and regular? You see the different graphs in the blue and red. Whereas the BMI after for the boot camp and regular, so that is, so this sort of comparison could be possible. Okay, we'll do it with the example, with the same example. So what could be some research questions that could be posed by the researcher? So research question, framing the research question is trying to see the claim is in support or not. So is there any difference in the BMI of the subjects in the two groups before the program? That could be the first claim which a researcher wanted to test. The second one, is there a difference in the BMI of subjects in the two groups after 1 week of program? So these two comparison could be possible. I mean, the testing the claim could be possible. There could be a third one, not much interested, like do both the groups lose the same amount of BMI on average? So, okay, focus has to be first and second. Is there any differences in the mean between these two groups before the program and after the program? So these are the questions like the researchers are interested. to knowing. Okay. So, for example, the groups may be, I'm talking about the different groups or independent data for the different groups. So the groups could be different by the gender, like male and female, age group, or ethnicity, the treatment. Over here, we have seen in this case experimental group and the control groups, it's a treatment or the health status. So for the independent group or independent or the independent data for the different groups, the groups could be divided on the several bases, on the several characteristics. So this case is clearly we are trying to deal with the two different groups. So now the research questions. On average, was there a difference in the average BMI or mean BMI of the subjects at the beginning of the boot camp and the regular program? So that is the one research question. The second research question could be, was there any difference in the average BMI of the subject at the end of the boot program and regular programs? So the two different levels of comparison we are trying to do. So let's do this exercise now. What it says that on average, was there any difference in the BMI of the subjects at the start of the boot program and at the start of the regular program? So this is only a single case, the first level of comparison. Before, not after. So before, is there any difference between the mean value of boot camp and regular? That's why you see in the right side, you have the graph, only two box plot is there. One is for the boot camp and second one is for regular. So we are trying to, as a researcher, we are trying to make this claim that there is no difference, or we can say there is a difference between the mean value of BMI of the subjects in these two groups before the program, at the beginning of the program. Assuming both the population are approximately normal with not equal variances. So keep some of the assumption over here, because these assumptions are important while following the 7 steps. The first one is a requirement. So clearly it says that the population follows the, like it's approximately the normal distribution. It is clearly mentioned. And keep in mind, this sort of questions, we have the two different like categories. One is the equal variance and second one is not equal variance. So especially this is the case where it is clearly mentioned that the not equal variance. I mean, so they have the different standard deviation for the samples. So this is the case of, we'll treat this case as a non-equal variance. That you just keep in mind. So now we have the hypothesis. So keep this question in mind. We'll try to solve this one. Okay. So again, the 7 different steps. Requirement, the values of sigma 1 and sigma 2. So very important here on the top, it is given the hypothesis test for independent data. Clearly, this is the independent data, the different groups, more than one groups, but independent data, not the dependent data. And this is the separate variance t-test. Why? Because in the question itself, it is mentioned here with not equal variance. See the last word, few words, approximately normal with not equal variance. So it's the variance are not equal. So that is means separate one, separate variance t-test. As I said, it's a sample. We have to use the t statistics because sigma 1 and sigma 2 is not given. The standard deviation for the sample for the population 1 and population 2 is not unknown. And we assume that population variance are not equal. And these two are these are the requirements. The two samples are independent, both samples are drawn randomly, both samples has the sample size greater than N125 and N225. So these are the assumption of the requirement to fulfill. So what is the second step? So the second step is here important. Mu1 minus mu2 equal to 0. That is the null hypothesis. What I'm saying that? Mu1 and mu2. So I'm assuming that mu1 is the mean for sample 1, mean value for the sample 1. Or you can say the sample 1 is treatment group, whereas mu2 is the mean value for sample 2, that is control group. Try to frame the null hypothesis and alternative hypothesis. What could be the null hypothesis? H naught. H naught is there is a no difference between the means. There is a no difference between the means of these two. So that means the H naught could be or will be mu1 equal to mu2. Whereas what is the alternative hypothesis? Mu1 not equal to mu2. Remember, this is very important step. So what we can do, we can further write it down like this: mu1 and equal to mu2. So that means mu1 minus mu2 equal to 0. That is the null hypothesis. In a more profound way, we can rewrite it. So just take it to the left side: mu1 minus mu2 equal to 0. That is the null hypothesis. And then similarly, the alternative hypothesis will be mu1 not, sorry, it will be mu1, it will be same as a mu1 minus mu2 not equal to 0. That is alternative hypothesis. Keep that one in mind. It's very important. That's what it was written here. Let me go back. So the stage second, the null hypothesis H naught is mu1 minus mu2 equal to 0. The difference of the averages of the two population is 0, and there is no difference in the mean. Try to interpret in your own words, in your own mind. And the second alternative hypothesis is mu1 minus mu2 not equal to 0. So the difference of the averages of the two population is not equal to 0. Then the stage 3 is significance level, either 5%, 1%, 5%, 0.05, 1%, 0.01, those kind of consideration. All the 7 steps are almost similar the way we have done it for the single population. This is number 4, T statistics. So since it is a 2 population or 2 samples, so we have x1 bar for the mean for the first sample and x2 bar for the means for the second sample. So x1 bar minus x2 bar whole minus mu1 minus mu2. And you see the mu1 minus mu2 is always 0 because you check your null hypothesis. It says that it's 0. Divide by capital S1 square by n1 plus capital S2 square by n2. So what is capital S? It's a standard deviation for sample 1 and a standard deviation for sample 2. Whole square root with degree of freedom V. And how to calculate V? You have another complex formula for that. In the right hand side in the table, you could see S1 square by N1 plus S2 square by N2 whole square divide by blah, blah, blah kind of. I mean, you don't have to mug up, you don't have to remember these formulas. It will be given in the example at the end. Otherwise you just keep all this formula ready somewhere because you are allowed to take 2-page cheat, like 2 pages back-to-back written, handwritten, or the printed steps in the exam. So just keep yourself ready with all this one. Only the thing is you have to apply this one. Application is important, not the memorizing anything is important here. So you have all these things. You know, you will read the question and you will have all these like the average, mean, standard deviation, everything. You will have n1 and n2 is the size of the sample 1 and size of the sample 2. Then you will get the T statistics. Based on the T statistics, next step is use the table, find out the p-value, corresponding p-values. Again, remember, if it is a 1 tail, 1 times. If it is a 2 tail, 2 times. So the same thing will be here as well. Then your decision, rejecting H0 or not rejecting H0 based on the p-value and level of significance comparison. And finally, you are making a conclusion, either that there is no difference between the average values or there is a difference between the average values. Till now, any doubt? Then we will start with the sum. Mark your attendance, those who have not marked. And let me see if is there any doubt with anyone. Let me scroll. Stop me if anything is not clear. I'm trying to Go ahead with as smooth as possible, but just let me know if anything is not clear, because the uh, just write down in the chat box so that I can understand and I can repeat, or otherwise I'm assuming that everything is clear. So just go ahead with the example, do this. Keep this one in mind, how to calculate t statistics, how to calculate degree of freedom. So remember, in that single population case, n was a size and the degree of freedom was n minus 1. But over here, you need to see the two different samples. Then you have to see, is it a separate variance t-test or some other type? Because this is like separate variance, unequal variance. But the formula will change for the equal variance. We have the next exercise, next sum, where it will be written in the exam. It is a equal variance, and that is also known as pooled variance. So in that case, calculating t statistics will be different. Calculating degree of freedom will be different. So just you need to understand. You need to be careful in terms of applying the tools. That you have to master it, right? Let's do this sum then. I'm assuming that we all are on the same platform. So for this sum, the same sum, like on average, was there a difference in the BMI of the subject at the beginning of the program for both the groups, boot camp and regular group? And we have to claim this one at alpha equal to 0.05. So level of significance is given 0.05. Assuming both the population are approximately normal, so criteria somehow is fulfilled with not equal variance. So not equal variance means it is a case of separate variance t-test. And what is given to you? The sample statistics for all 20. You see here, all 20, A to J, BMI before for the boot camp, K to T, BMI before the boot camp. So for all 20 participants, all the data is given. I mean to say the before. And we are trying to say, is there any difference between these two? Me, before the training program. So in additional, what is given to you? You see here, mean for X1, mean for X2, mean for boot camp 28.49, mean value for regular 27.40, standard deviation for boot camp 2.97, and standard deviation for regular is 2.38. Why these are important? Because you need to calculate the statistics. So you wanted to have X1 bar, X2 bar, S1 square, S2 square, and N1 and N2. So I think in this example itself, everything is given what is required to you, required for calculating the t-stats, even the degree of freedom value, that is V. So you have all the values here. Why you're waiting for now? Can you start? Do it manually, because this exam is like meant for the manual exam. But could remember, we can do it more smartly using the Excel sheet. I can show you that one, but just try to do it manually, maybe once. Can we start?
Sir, the regular group is the treatment group and the boot camp is the control group?
No. Come here at the beginning. Can you read once again the last paragraph or somewhere? Just have a...
Okay, yeah, boot camp is regular.
So you are giving the special training. That is your treatment group. But those who are not getting any treatment, they are the control group. So regular means controlled. Think about a similar case, like suppose Amit Kumar has designed a new capsule program in the statistics for 24 hours. What I can do is I can select 20 students from you all. I will divide into two different groups. One group will be given normal teaching of the statistics. Again, this group will be given a capsule program design, especially design. And at the beginning, I will conduct some exam and I will get some scores, like how much is your performance. And the same thing I can do at the end. And then I will try to see is there differences between the mean and before and after, something like that. So always keep in mind, one group is the treatment group. Over here, it is a boot camp program. and the regular is your control group. So no treatment.
Okay.
So did you apply all the 7 steps here? Can we go through the 7 steps and see? Requirement is fulfilled. Are you able to frame the hypothesis 1 and 2? I mean, null hypothesis and alternative hypothesis? It will be same, because the question is, was there a difference? So you're not sure which one is before, like more or which one. It's not one directional, it's a two-tail. Was there any difference, or is there any difference? Means both are not equal. So do you think it is a one tail or two tail? Clearly it is a case of two tail. So the null hypothesis and the alternative hypothesis will be same. Mu1 equal minus mu2 equal to 0 for null hypothesis, and mu1 minus mu2 not equal to 0 will be your alternative hypothesis. What next? You need to calculate degree significance level is given 0.05. So try to calculate the T statistics. Do it fast. All the values are given for the T statistics. Whatever the value is required, it is given to you. Find out the T statistics. T statistics is x bar minus x2 bar, right? So let me see what is x1 bar. 28. X1 I'm assuming for the boot camp, and 27 regular I'm assuming the x2 bar. So x1 bar minus x2 bar. So it's a 28.49 minus 27.40. Remember, this output will be given to you. Otherwise, you can't proceed. Otherwise, Excel will be given to you, that use the Excel sheet and find out. 27.40 minus mu1 minus mu2, that is 0. Use the hypothesis I said. Then you have S1 square. What is the standard deviation for sample 1? 2.973. 2.973 square by N1. N1 size is 10. In this case, it is N1 is 10, N2 is 10. Altogether it's 20. So N1 is 10 plus S2 square. Capital S2 2.38. 2.382 whole square, S2 square by N2 whole square root. What is the T value? Find out the T value using that formula. Yes.
Sir, where did you get 10? Sorry.
Which one?
10.
10 is the sample size. What is, you see how many participants are there for the boot camp?
Okay.
A to J, 10.
Okay.
And for the regular K to T, 10.
Okay.
And even that was given at the beginning that 20 students has been taken, 20 participants, and they are divided into 2 different groups. So
Okay.
keep that one in mind. It will be somehow it will be given clearly.
Okay.
You don't have to worry for that. Find out the T statistic value, T stats value. Somehow someone has to do this one bit fast, because it involves a calculation. So just, and someone can do the this one, can calculate the V value as well, the degree of freedom. I just wanted to know how much is the degree of freedom. I could suggest somebody can do T stats and somebody can do the for V. We could see like this Excel can do this sort of work very, very quickly, but unfortunately in this exam you are not allowed to use. Did you get any T stats value? Anyone?
0.9048.
Exactly, 0.9048 or 49. So what we can do is, I'm keeping as a round up 0.90. You say 9048. So 904. 48. 9048. Keep that one in a mind, or 49. Similarly, you will get the V value. You use the apply the formula and get the degree of freedom. You're right. It will come 0.9048. Can we do the quickly this calculation of V, degree of freedom? That's why more calculation is required. It's a bit, that's why like it's advanced level of hypothesis testing, more than one sample. So I don't think so.
I have a question.
Yeah, please ask.
In the previous step on the t-test, where did you get where did you get 0? Because x bar is 28.49 and x2 is 27.401, but where did you get 0 from?
For mu1 minus mu2?
Yeah.
You see the hypothesis, H0, what is that?
Oh yeah, -1, -2. Okay.
Yes, yes. Anyone, did you get the value of V? So next step is to find out the P value, and for that you need degree of freedom. So another step is important, unless you have the T stats value, but you also need to have a kind of the degree of freedom, so that you can look at the table in order to find out the P values. So quickly, can you just let me know what is the what value you are getting for the degree of freedom? Did anyone get any value for V? It will be around 18 point something.
Hmm?
How much is degree of freedom?
I'm getting 17.1941.
Okay, 17.1941.
1941.
Okay, can we round off? Okay, I'm assuming it. No worries. So V value is 17.1941 something. Can we round off it? Because the degree of freedom we wanted to have in a one digit. The table gives you 17, 18, 20 kind of. So just assume the degree of freedom 17. Can we quickly go back to the T table and find out the p-value? Others you can do later on, you can calculate the p-value, but just assume the 17. So the degree of freedom, it's not size, so degree of freedom is 17. I just make it as a round off. I just round off the 17.1941 to 17. And now what is the value of the T-stat? 0.904, 9048, where it comes? 90 will be more closer to 863. Isn't it? 863 will be more closer to 9.940, right? And you see the corresponding value?
Yes.
How much it is coming?
20.
Exactly. So, what is the final p-values? Is it a one tail or two tail?
210.
Is it a two, yeah, this is the case of two tail because not equal to. So 2 times 0.20, right? So your p-value is coming 0.40. And what is the alpha value in this case? 0.05. Now, p-values 0.40 is less than 0.05 or 0.40 is greater than. It's 0.05. Which one is? I think this is incorrect.
So could you show us the board?
Wait, could you please ask what is the question?
No, I just wanted to see the board.
Oh, sorry. Yeah, I changed it. Now it will be all right. Okay. What I was telling that p-value is 2 times. It's a case of two tails. So 2 times 2.20, so 0.40. Alpha value is given 0.05. We are testing this proposition or this hypothesis at 5%, 0.05 degree of significance. Since 0.40 is greater than 0.05, so p-value is greater. So in that case, not reject. Remember, not reject null hypothesis. If p-value less than, then H0 must go, reject H0. But if since p-value is coming greater than this level of significance, so not reject H0. If we are not rejecting H0 means, what is that H0? Mu1, what is H0? H0 is mu1 equal to mu2. So we can say that there is a, how could you interpret this one? We are not rejecting the null hypothesis means we have no evidence for saying mean value is different. So that was our null hypothesis. So the mean value of the BMI for both the groups before the treatment is same, because we are not going to reject the null hypothesis, means they are same. And that is the conclusion you have made. Did you get that conclusion? Non-rejection of H0? Let's do this one, the same sum using the Excel sheet. I'm showing you here. I'm trying to do the same thing using the Excel sheet. Where is Excel? Okay, Look at here. Boot camp and regular. Is it the same value? 25, 24.7. 25, okay. Sorry, not. These two data are given, right? For the boot camp, 10 participants, and for the regular, 10 participants. And these data are before the treatment. So what we can do is, using the Excel, you see, just keep noting what I'm doing here, or you can do in parallel. Find out where is the data? Yes. This is the case of what I said, unequal variance. It was given in the question that the populations are normally distributed with unequal variance. So use the t-stats to sample assuming unequal variance. Okay. Data range first, boot camp. Data range second. Are you able to see the Excel sheet?
Yes.
Okay. What is the hypothesized mean difference? In this case, mu1 minus mu2, 0. Alpha value at 0.05. We are including the level. I have included the level, so tick that one. Output range, I wanted to have over here. Let's see what is coming out. Yes. See, the result is in front of you. Excel does the same thing very quickly. No need to have a complex formula to understand VOF and all. You see here? Yes. Somebody has given me the degree of freedom 17. You are right. And we also got, and 17, actually it came around 17.1941, but you have to round it off. So make it the nearest digit, whole digit. So 17, correct. We got the mu1, you see what is the t-stats? How much we got t-stats? Is it the same? Our one is 9048 and over here exactly the same. You did a great job. You found the same as what Excel is giving to you. And what is the next one? Is it a case of two tail or one tail? It's a case of two tail. So we have to look for the p value for the two tail. How much did we get? We got the value 0.40. Isn't it? That is like close to 0.37 or 0.38. Both are same. So based on this Excel sheet output, what is your conclusion? Non-rejection of H0, isn't it? You are not rejecting because alpha value is greater than, the p value is greater than alpha. Alpha is 0.05. How quickly we did the same thing using the Excel.
Sir, sorry, can you do the Excel part again? Like after the t-test, what do you press? I was still putting the data in, sorry.
You want me to do once again? I can do it here.
Yeah, thank you.
Remember the case. Is it like which one you have selected? Is it t-test you have selected? Did you select?
Yep.
You need to select two sample assuming unequal variance because the question is separate t-test, separate variance. So unequal variance. It was given in the question.
Okay, hold on.
So range 1, boot camp. Range 2, regular. I have added the level. So I put level, I tick the level. Hypothesized mean difference, mu1 minus mu2, I'm assuming in the null hypothesis it's 0. And then alpha value 0.05, output range, just keep it, I'm selecting any free space here in the same one, and then okay. You will get the same thing again.
Hold on, sir.
Did you get the same thing or not?
Hold on. Okay. Yep, okay.
And did you match the what manually we did t-stat 0.0948? Same thing is coming.
Yep, I got the same thing.
The degree of freedom 17. Yes, it is coming here 17.
Okay.
P value is coming in our case manually 0.40, which is closer to 0.038. So almost
Okay.
both the answers are same.
Okay, got it. Thank you.
So if you understood the first sum, now it's time to move to the second one. Because of a bit slow and I need to be a bit fast. So, okay. So you understood using the Excel sheet. Can we do the exercise second? Read the question. You are a financial analyst of a brokerage firm. And the question is there a difference in dividend yield between stocks listed on the two different stock exchanges, New York Stock Exchange and NASDAQ, NYSE and NASDAQ, both are from US stock exchange. So the data, following data is given, I mean to say sample statistics. So sample size for NASDAQ stock shares are 21, for NASDAQ it is 25. Sample mean X1 bar for the NYSE is 3.27, and the same sample standard deviation is given S1 and S2. Assuming both the population are approximately normal, it is given. So you don't have to worry about the requirement. The kind of exam you're giving, so no need to worry about the requirements and all this time. But fortunately on the paper, I could have requested you to write each and every, all the 7, follow the 7 steps and write, and I could have allocated you point-wise or stage-wise marks, like step-wise marks, but unfortunately not this time. So what is given, it's a normally distributed, very important, with equal variance. In the previous case, it was written unequal variance. So this is the very important thing you have to understand before applying any formula. You need to read the question properly. You should not, if it is an equal variance, you need to apply the T statistics for calculating for the equal variance, not the separate T variance. So I'm giving you the keep on saying the same thing. Keep in mind, you need to be very careful what is given in the question, and then accordingly you apply the formulas. What is the degree of significance? Alpha is given 0.05. It looks like everything is same as the previous question, right? You have given sample mean, distribution, the standard deviation, N1, N2, everything. Only one difference is, in this case, they are saying that you need to consider or assume the sample, the population with equal variance. So in this case, all the 7 steps will be similar, except the value, calculating the value of except the step number 4. So in this case, T statistics will be calculated using different formulas. X1 bar minus X2 bar minus mu1, mu2, that is the same, but at the bottom, you can see at the denominator, it is SP square. That is the pool variance. Please note it down somewhere. SP is known as pool variance. So SP square root then 1 by N1 plus 1 by N2, and then you have a separate calculation for the SP square, pooled standard deviation, because we have 2 different standard deviations. So it's a case of, you know, the same variance. So another name is pooled variance T test. On the top you could see the hypothesis test for independent data, because the 2 sample data are independent. One is taken from the NYSE stock exchange, whereas another one is NASDAQ. So it's a different one. So hypothesis test for independent data, pooled variance T test. Why it is pooled variance? Because it is given in the question equal variance. In that case, you have to take out, you have to calculate SP. That is the pooled variance. SP square is the pooled variance. But remember, over here, the calculating the degree of freedom is no more complex. In the second case, in the case of pooled variance T test, degree of freedom is N1 plus N2 minus 2. Simple. N1 is given, N2 is given, minus 2. So what is the degree of freedom over here? Can anybody tell what is the degree of freedom for this sum?
Wait, sir, sorry. How come the equations are already different in this exercise?
Why?
Yeah, so I didn't catch the reason, sorry.
Pardon once again?
Yeah, like why are the equations different already?
Oh, okay, because this is the case of pooled variance.
Okay.
Yeah.
What is pooled variance?
I mean, it's the equal variance. Pooled variance means if it is an equal variance, you need to find out something like SP. That is known as pooled variance. But keep in mind, over here in the question, at the right bottom, what is written? Assuming both the population are approximately normal with equal variance.
Okay. Okay, okay. Yeah.
So whenever
see.
it is the equal variance, that is the case of pooled variance.
Okay, thank you.
Whereas in the exercise number 1, let me go once again back because this is important here. What is written in the last sentence? Assuming both populations are normal with unequal variance. So
Okay.
unequal variance means separate t-test.
Okay, thank you.
Whereas in the case of equal variance, you have the case of pooled variance t-test. Statistics, we just have to follow. We are not the founder of the, we have not made all these things complex. So it is what some of the great researcher mathematicians, they have done it long back, and we are just trying to solve and see is our claim is right or wrong. That's what we are interested in.
Okay, thank you.
It's just blindly you have to follow, but understanding the application is important, like which term is used, like how to respond to each and every term. So in this case, degree of freedom calculation is no more tricky thing. It's a n1 plus n2 minus 2. Can you tell me what is the degree of freedom for this case?
44.
So yes, n1 plus n2, 46 minus 2, it's 44. So can we do it now? So for this sum, can we go ahead with the sum? Find out the t-stats. I'm not telling you to go ahead with the requirement or not. Just analyze this one. Is the requirement is met or not? If you have any doubt, just let me know. Otherwise, simply jump to the stage number 4. Stage number 4 says that calculate the t-stats. You have all the information given. Can you calculate the t-stats? In this case also alpha is given 0.05. T-stats. What is the formula for T-stat? X1 bar minus X2 bar. So what is X1 bar? 3.27 minus 2.53 minus mu1 minus mu2. That is again, I'm sure like you will be able to generate the null hypothesis and alternative hypothesis. It will be same. Null hypothesis. What is the question? Is there any difference? Is there any difference? So again, what is H naught? Mu1 minus mu2 equal to 0. Alternative hypothesis will be mu1 minus mu2 not equal to 0. Because is there any difference? There is no difference. So we are not sure about the direction. Is it a one tail or a left tail or right tail? So it's clearly the case of two tail test. So that one you need to, this is the case of again two tail test. So keep in mind what is 1 point. Okay, so formula SPA square. You need to find out SPA square. SP is known as pooled variance. Y1 by N1 is how much N1? 1.3, no, 21 and 25. 21 plus 1 by 25. So let me take you to the whiteboard. T start 3 point like x1 bar minus x2 bar minus 0 SPA square 1 by n1 21 plus n by 1 by 25, and degree of freedom is n1 plus n2 minus 2. So 21 plus 24 minus 2, that is 21 plus 25, sorry, 21 plus 25 minus 2, that is 44. So we got a degree of freedom. You need to find out what is the t-stats value. And for that SPA square, you have a separate formula for calculating the SPA square. Can anybody do it quickly? For SPA square, it's easy now. Let's see like how they did it, and just you also try to do it. Could you see the slide? They have solved it here. 3.27 minus 2.53 minus 0. SPA square, you will supposed to get SP square value 1.5021. 1 by 21 plus 1 by 25. Find out the value of T stats. You will
Sir?
get 2.040.
Sir, how do you get the SP squared?
Could you see the slide?
Yeah.
It is written here. You have to use the formula. SP square is equal to N1 minus 1, S1 squared. So just use the, you have all the values.
Okay.
21 minus 1, 1.3 square plus everything is in front of you. You could see how they have done it. And then they replace the 1.50 to the original one, T stats. So I'm assuming that you will get this T value. Can we go ahead? We will do it the same thing with the Excel also. So can we go ahead with this one? What is the corresponding P value? Anybody? Can you get for this one? Degree of freedom 44 and the T value is 2.040. Can you get the corresponding P value? Anyone? So 44 is not given in the first one. So you need to use the another one. Remember in the exam, I have not given you the second T stats table. So keep that one ready with you. I mean, you should not ask like, where is this formula and sir has not given this formula and all. You have right, like you can keep it everything ready in advance, well advance. I'm not sure I will be there or not there. Maybe the NIC management, they will be conducting separately. So maybe the chances are there I will be not there for the 2 hours of your exam. So that you should not ask for anything that it is not given and all unnecessary. Don't try to, especially in terms of the, the formulas and all. You have everything. Just keep yourself ready before sitting in an exam.
Wait, it's not going to be online, yeah, the final exam?
Probably online.
Probably online. Okay.
Yes. Nobody will be there to control like how you are doing at your own end, but you need to be careful. Like you just keep ready with all the steps, calculator, all the formulas and all which you think is necessary. Although I have given also like the same thing at the end of your exam paper and all the formulas, but if something I have missed out, don't like request someone that it is not given, I'm not able to proceed and all unnecessary. Don't try to. You have freedom. You just keep all your important steps ready with yourself. You have all the access of all slides, all teaching materials, all tutorials, everything. So that should not be the case, I mean to say. So let me open this one. What is the P value you get? So I have opened the another. Yeah. So what is the degree of freedom here? 44. So let me draw some here. Over here it's 44. And then what is the P value? T stats value 2.040, 2.04. So 2.04 is close to here, right? Yes, 2.0 is close to this value, 2.0154. Isn't it? Yes, with the 44 degree of freedom. 44 degree of freedom. See the value, what is the corresponding value is coming? 0.025. Since it is a two-tailed, 2 into 0.025. 0.025. Again, this is the case of bit critical. It's a 5%. So how much it is? 0.025 is 0.05. How to make the decision? I need an expert opinion here. Let's see through the graph. Let me write down here. What is the t value at 0.05? T value is okay. 0.025. What is the t value? The case of 0.025, and what is the t value? 2.0154. 2.0154. Okay. Okay. See here. With the t stats or t table, what I found is at 0.025, this is the t value, 2.0154. But our case is t stats. And again, the same thing I did it for this is the case of two tail. So I did the same thing for left both sides. So over here is minus 2.0154. Did everybody understand how I got this? How I get this number?
Yes.
2.0154 at 0.025. Our t value is, and if you remember, this is the area of rejection, and these two are area of non-rejection. 2.040. 2.04. So 04 will be right or left to this point. 0.040, 0.15, and this is 2.040. So surely it will be the right side, isn't it? So this our t starts value 2.040 will be right to this point. These two are the critical point. 2.015 and minus 2.015 are the critical points, CV, critical values, if you could remember. So our case 2.040 will be slightly right to the 2.040, will be slightly right to this critical value, and that will fall in the area of rejection. This is the area of rejection, whereas these two are the area of non-rejection. So on the basis of t value and p value calculation, what you can say that since the t value lies right one area of rejection, means we will reject the H naught. So what is the final conclusion? Reject the H naught. Let me know if it is not clear. Reject H naught is the final. Why? Because the t value is slightly right to the critical value, and we know these two are the area of rejection, whereas inside these two are area of non-rejection, critical value. So we can say that we should reject the null hypothesis in this case. I mean, what is the reject the null hypothesis means? What is our original hypothesis? H naught. They also did the same thing. You see here 2.145. Yeah, this slide also take you to the same conclusion. Reject the null hypothesis. So we can conclude that there is a evidence of a difference in mean. Null hypothesis is there is no difference, but we are rejecting the null hypothesis, means we found the support for alternative hypothesis. So we can say there is evidence of differences in mean value of these two stock exchange shares. Is that clear? Or any doubt? Take your own time to make, in order to make the final conclusion. You take your own time, but just let me know if anything is not clear. I will be happy to repeat that one once again. You can write in chat box if anyone is, if you think it is not clear for you, just let me know. You can do the same thing with the p-value as well, right? But only the thing is, this is a bit critical case where if you go through the original, like traditional way of calculating p-values, you will get the p-value same as the alpha value. That's why we need a more clarity using this one. Otherwise, we could have gone straight away with p-values 2 times the. You can do that one also, but you will get exactly the same similar value as 0.05, and it will be difficult to say it's 0.05 is less than or greater than 0.05. For that, we need a bit more clarity, and we have seen that it's a slightly right to this one. So this falls under the area of rejection. So straight away we will reject the null hypothesis. Okay. So now, what we understood? We have understood the 2 different cases, two different samples, especially the independent groups or independent samples. But now the second stage, we'll try to understand dependent samples. So there are different names. It's a matched, or it's a dependent, or it's a paired sample. Or in this case, we carry out one sample test on the differences to see the if there is a differences in the values. Okay, just the notation for the paired sample or the dependent sample or the matched sample is mu d equal to 0. Okay, hang on, no need to worry. First, you try to understand the dependent sample first. We understood the independent sample, right? Boot camp and the regular one. They were the independent samples. But now we are talking something which is dependent sample. So let's see the one situation first. What exactly the meaning of the dependency? The same experimental design. I will try to let you know what is the meaning here in the case of dependency. So if you could remember, in the previous case, we tried to compare across the level, same level, in the case of independent samples. But in the case of dependent sample, we can do one sort of claim analysis. We can do some one case or one sort of comparison. What is that? Imagine that you are taking at one group at one time, like experimental group. And for that, what you did, you have a BMI values before the treatment and after the treatment. So you have the two sample data for this group, and these 2 data are dependent one. So the question is that there could be a question of in terms of claiming claiming the test, in a sense that is there any difference between the mean value before and after the treatment for the experimental group. We can do the similar sort of testing the claim for the control group, while saying that is there any difference between the mean values of the control group members before and after the treatment. So this sort of analysis is somehow where you could see it's a kind of dependent. So how to define the dependent here is when the two observation arises from the same source, then we could say that they are the pair data. Examples are there like measurements before and after the sums treatment. Is it the same source, same people? I'm getting the two different data for the same people before the treatment and after the treatment. So it's a dependent, it's a matched, it's a pair data sort of. Another example, weight of individuals before or after a diet program. Is it the same person? I'm taking 2 times the data. But this was not the case in the previous one where we have seen, we were doing the comparison between boot camp and the regular. There were 2 different groups of people. The test score measured before or after a training program. So all these are examples which says that, which indicates that we are talking about dependent data, or either it may be a paired or matched data. So the research could ask this, like you can, as a researcher, you can formulate similar sort of question. Is there a difference in BMI of boot camp subject after 1 week of the program? I mean, there is a comparison between, is there any difference between the BMI of the same subject, boot camp subject, before and after the training program? Or maybe we can have the second sort of claim or questions. Is there any difference between the BMI of the regular training subject before or after the treatment, or after 1 week of the program? So this is the clearly, these sort of questions are clearly the case of dependent data. Okay. Taking back the same example of BMI. What is the question here which we wanted to test this claim? On average, was there a significant difference in BMI after 1 week of the boot camp program at alpha 0.05? So after reading this question itself, you have to think about, is it they are asking for dependent data or independent data? This is clearly more than one data, more than one sample. You could see BMI before sample 1, BMI after sample 2. This is clearly the case of more than one sample data. Okay, that is clear. That you have X1 bar, X2 bar, S1 bar, S2 bar. That is clear. But the next question is, are they asking for dependent data, or this case is the case of dependent data or independent data? BMI before and BMI after of the same person, it's a matched data.
Dependent data.
So it's a dependent data for the same subject. See, in the previous case, the total 20 respondents we were taking into consider, but over here the same 10 people before and after. So this is a dependent data. So can we go ahead and measure this one? Okay. For this case, for the dependent case of more than 2 samples, what we have to do? We have to follow the same 7 steps. This is also known as hypothesis test for dependent matched pair data. Remember, dependent data and matched pair data. So step 1, step 2. Okay, what interesting is step 2, hypothesis forming. In this case, we use a single set of hypotheses. I mean to say mu D. D stands for difference. So average difference in the population equal to 0. I mean to say, if we are saying that there is no difference between the BMI before and after, that means we are saying mu D, the difference, is 0. But if the claim is there is a difference between the same respondent before and after, that will say there is a difference. So the mu D not equal to 0. So what is the null hypothesis here? Mu D equal to 0, whereas the alternative hypothesis is mu D, that is D stands for difference between the same. So mu D is not equal to 0. So that is the average difference in the population is not equal to 0. Level of significance, either 95 or 99, depending on that. And the T statistics. Over here, you have the calculation, another sort of calculation. Again, this calculation, I mean to say the formula will be given. You just have to find out what is the meaning of the notation, and you just have to apply. So T stats is D bar, D capital bar minus mu D. What is the mu D from the null hypothesis? mu d is always 0. It's same like mu1 minus mu2. We have seen in the previous case, it's 0 from the null hypothesis. So mu d value is always 0. Divide by SD, square root of n, with degree. In this case, degree of freedom is, since we are considering a one sample, so n minus 1. Then p value, decision, and conclusion. So just take an example. Okay, so T stats, D stats, and what is D bar? It's like differences, average of the differences. So D1, difference 1, difference 2, difference 2, difference 10, divide by 10. That is D bar. And what is the standard deviation of the difference? Di minus D bar. It's the same way we have done it. If you could remember the standard deviation calculation for x1 minus x1 bar. Same thing like that. Let's take one example. Okay, let's take the same example for the, what is the question here? We'll do the same. Okay, what try to understand the question. We'll do it manually and we will do it with the Excel sheet both. At 5% significant level, was there a significant change in BMI after 1 week of program of boot camp initiative? So we have to consider boot camp only, the respondent from boot camp, and we have to see before and after. So if you go back to the original data, yes, this is the original data. Only we have to consider boot camp before and after. So you have 10 plus 10, 20 values, right? Let's do it using the Excel first. You see how easy it is to do it using Excel. Okay, this one is. Read the question. They are asking for, was there any difference between the mean before and after in the case of boot camp? So we are not considering the regular group. We are only considering the boot camp group. So I have the BMI for the boot camp groups, which the members A to I, A to J, I think, A to J, before and after. And you can see in the original one also, it is the same one. So the question is, was there any difference? What we can do using the Excel? More smartly, what we can do, we can choose the data analysis. And now you tell me which option I should take.
The equal one.
Is it an equal one or is it the paired two sample of means?
Oh,
It's a paired one, more closely. And why you are making an assumption of it's equal variance? It is not given anywhere. So which one is more appropriate? Do you think this is a paired or matched sample? Before and after training program, before and after doses, is it a paired or matched? So the most appropriate is paired two sample of means. And we are not sure about the equal variance or unequal variance. But we know that it is a case of, like the paired match. It's a dependent data. So see the t-test for the two sample, equal variance and unequal. It's a two sample, but this is the case of the single dependent one. It's a more appropriate is paired two sample of means. So click that one, provide the range one. Provide the range to the boot camp after. What is the hypothesized mean difference? Mu d as a null hypothesis, it is a 0. I'm using the level, so click level. I'm trying to check it 95% confidence level. What is there in the question? Yes, 95%. So 0.05 output and then press OK. What is written on the top? It is t-test paired two sample of means. That's what we are saying, that it's these two samples are paired, dependent on each other, before and after of the same respondent. So what is the t-stats? You will get the same t-stats if you apply the formula. Which formula I'm talking about? I'm talking about this formula. If you use the formula d bar minus mu d divided by sd root upon n with n minus 1, you will get the t-stats and the p-value which is there on the Excel sheet. So what will be your decision? T-stats is 8.505. Okay. Is it the case of two-tail test or one-tail test? Think about that. You see the degree of freedom is 9, n minus 1, because we are considering this one as a 1. So as per the formula, it's n minus 1. So 10 is the sample size. So 10 minus 1 is 9. That is correct. Decide, is it the case of one tail or two tail? Is it the case of one tail or two tail? What is null hypothesis here? H naught is mu d equal to 0. The difference in the mean is 0. We are saying that is null hypothesis. What is alternative hypothesis? Mu d not equal to 0. If something not equal to, clearly this is the case of two-tail test. We are not saying that the BMI after the treatment is higher than BMI before. That could be a case of right tail. If the claim is BMI after the treatment is lower than the BMI before, that could be a case of left tail. But we are saying that there is no difference between the BMI before and after the treatment. So in that case, we are not sure about the direction. So clearly this is the case of two-tail test. So mu d is 0, means the difference in the mean we are considering 0, means there is no difference before and after. And we are talking about the paired data match, where the paired data or match data of two samples. Whereas the alternative hypothesis is there is a difference between those who perform the training, who has participated in training. So there is a difference in their performance. I could say that there is a difference. Those who have taken the proper training of customer handling, the number of complaints which came later on and which was before, there is a difference. So sort of analysis. So this is the case of paired data, dependent data. I'm talking or discussing over here is dependent data. So clearly this is the case of two-tail. So in this case, you got the t-stat. If you use the same formula, you'll get the t-stat same as 8.05. And then at the degree of freedom 9, you see the p-values and you take the decision. Over here, p-values is given. Excel gives you the p-values. So look at the p-values for the two-tail test. What is the value? It's a 0.00000, which is, what do you think? What is it? This value is less than 0.05 alpha. It's a very, very minimal value, right? 0.000. So the p-value is coming 0.00001 or something, right? that of course that will be less than 0.05. So p-value less than level of significance. If p-value less than level of significance, that means p-value is less, h0 must go. Must go means reject h0. What was the h0 reject? H0 means we found no evidence for this, and then we found support for this. We can say that there is a, I mean, those who participated in this treatment or in this program, there is a clear difference. I mean, the values, the mean values, BMI values after and before, there is a difference, significant difference at 5% significant level. So that conclusion you have to make using the p-value. You see, like manually, if you are, suppose you are doing this one, the same sum using like manually. Take the example of exercise number 4. Assume you send a salesperson to a customer service training workshop. Instead of healthcare industry, now we have some example from the business world. So assume that the 5 sales executive, you send them for some sort of training workshop. Has the training made a difference in the number of complaints? As a manager, you wanted to see, okay, 5 executives were working under me, and I thought like they are not really good in terms of customer handling. So what I suggested them that go and join some sort of training program for 1 week or 1 month. And then after that, I wanted to see, is there any difference between the number of complaints before the training program or after the training program? I'm expecting that the training program should make a difference. I mean to say, it should make it should lower down the number of complaints. Because if your your executives are better informed, better trained, means the number of cases, the complaint cases will be lower, right? So that is my expectation. But I wanted to check that as a marketing manager. I wanted to check, is it the training which my staff has undergone, does that make any difference to them or not? So what I have did, I have the salesperson CB, TF, MH, all 5 names, and then before, number of complaints before the training program. So person name CB, how many monthly complaints were coming? 6 numbers. For another 20, so like that. And the number of complaints after the training program for the next, like one month, we have noticed that 46200. So you have one value before, one value after. So what is the difference? 2 minus 1. So that is 6 minus 4 minus 6 minus 2, 6 minus 20 minus 14, 0 minus 0, 0, and 0 minus 4. So you see the DI, the difference, and then sum of DI is minus 21. So in order to calculate capital D bar, it's the same like the average of the difference value. So minus 21 by number of n size is 5, so minus 4.2. Similarly, you will do for the SD, the standard deviation in terms of the differences, that you will get 5.67. And then you have to apply with the formula. So what is the G bar? We got minus 42 minus 0 divided by 5.67 whole square by root number of size 5. So you will get the T stats value minus 1.66. And what is the degree of freedom? N minus 1. So N value is 5 executive, so it is 4. And then you can proceed with the minus 1.66 at 4 standard deviation, degree of freedom. You try to get the p values, and then accordingly you take the decision. So what is the degree of level of significance? 0.01. Let's see here. In this case, we have level of significance. The exercise number 4. the question was has the training made a difference? I mean to say, is that mu d equal to 0 or not equal to 0? So clearly this is the case of two-tail again, because we are not sure is like performance went higher or lower. So the question is very plain in the sense, was there any difference the training made? So it's a clearly two-tail test. Okay. So how much, using the same formula, you will get the T stat value. Over here it is done, so you can do it later on and you will see that T stat value 1.66. And what is the degree of freedom? DF came 5 minus 1, 4. So can you get, and what is the alpha value? They wanted to check it at 0.0, means 1% significance level. So what is the alpha value? Alpha value is given 0.01. That is given in the question, 0.01 level. Use the T-stat table. Open the T-stat table and see what is the p-value coming. How much is the p-value? What is the p-value for n equal to 4? Okay, so n equal to 4. And your T-stat is how much it is coming? Minus 1.66. So if it is a negative, remember it's a bell-shaped symmetric, so consider, because there is no negative values of T's here in this table. So consider positive side. So 1.66, where is 1.66? Which value is closer to 1.66? I think this one. 1.533 is closer to T value 1.66. Whenever it is a negative T value, consider it positive, because the table is not giving you any value for the negative side. So consider, because it's a bell curve symmetric in nature, so consider right side, hand side. So at 1.66, which one is closer value? 1.533. And then corresponding P value is 1.0. So what is the P value? Since this is the case of two-tail, P value will be 2 times 0.10. What I'm saying that T stat is 1.66 and degree of freedom n minus 1 is 4. So you use the T stat table, you will get the P value 0.10. So but the real P value is 2 times, since it is a case of two-tail test. So 2 times 0.10. So it is coming 0.20. Now P value with alpha. Is the P value less than alpha, or is it a P value greater than alpha? Which one is the case? So P value is 0.20, and so this is the case. Second case is matching. So 0.20 is greater than 0.01. So in this case, we should not reject. So not reject. So the not reject H naught. We should not reject H naught because the P value is greater than 0.01. So this clearly this is the case of, see, P value 0.20 is greater than 0.01. So not reject H naught. You should not reject null hypothesis. So it means there is a, so what will be your conclusion? There is not a significant change in the number of complaints. That means if there is no changes, significant change in number of complaints, means can you say that the training program was effective or not effective? What is your conclusion? Anyone? Can we say the training program was effective or not effective? What is your comment? Based on this, if you are rejecting or not rejecting H naught, and H naught is saying that there is no difference between those who underwent the training program. So as a manager, what I will think, is it the right is what a right decision to take all the executive to through the program, or it was a wrong decision? Clearly this is the case of wrong decision, because we found that significantly, we found there is no difference between the number of complaints. I mean, the before the number of complaints and after the number of complaints was like, there's no significant, means we could say that not reject means we have a support of H0, and H1 says that there is no difference. So clearly this is a kind of indication, this is a kind of warning sign to the manager that in the future you should not send people for the training program or that specific training program, because the result is not making any impact. So overall, you have to make this sort of conclusion, and that the better decision making. Why we are using this inferential statistics? What is the idea behind of understanding all this, testing this claim? To improve the decision making. Okay, so let me have a quick recap what we have covered today. So we started with understanding the concept of experimental design, and with that we understood the independent data, the case of independent data or case of dependent data. So more recently what we did is the dependent data, whereas the initial 2 or 3 sums which we did was the independent data. So we are in the advanced level of hypothesis testing, and this was the last one. Like, you don't have to have more and more cases on hypothesis testing. So this was like, because the next week will be totally on the correlation and regression. So that is the last chapter. So this is the maximum which was prescribed in your syllabus. So I'm supposed to cover all this, but think about like, maybe if you take your own time, I can understand you guys, like most of you are facing a kind of difficulties, a kind of level of interaction is a bit low. That gives me indication that either I was like bit more fast, or maybe I have not done much justice. But what I'm suggesting you, please go through all these slides. It's easy to understand, and we are just looking for your application of the theories. We are not saying you to remember anything. Everything, all the slides, all the materials are in front of you, even in the exam. So it's up to you. Just think about what sort of question, what is there in the question, and then clearly based on that, that is the more challenging and critical thing over here. The moment you took the decision, okay, this is the clear case of the dependent data, 2 sample size and all, then you have all the remaining tools to proceed. But take that decision is like, will be challenging, and I understand. So with the practice, so this week you just in the coming tutorial also we'll cover the independent and dependent data access and the cases on the independent and dependent data. So you don't have to worry much about this one, and we know that Excel does the things very quickly, so more efficiently. So try to have a kind of manual practices, so that at least once you can do it. There is no need to do practice again and again. Most of the time, try to understand the similar sort of questions, analyze it, and just be confirmed that, okay, this is the case of this one, and then we have to apply just this formula. So just do it like more a little bit more practices, and the coming week, as I said, the tutorial will cover the more and more questions from these two, independent and dependent data. But remember, it's a case of more than one sample mean or sample population. So this is a bit, but if I could remember that, it's not much complex in terms of understanding the steps. Steps are almost the similar thing. Only the way you have to think about is how to calculate the t-stats. So, and for that, it's a kind of just application. If it is a 2 cases, 2 sample means, and there will be 2 different standard deviation values, n1 and n2 will be given. So those who are like not practicing much in terms of calculation, final calculation, try to have like more similar practices on your using the calculator, I mean to say. Just like for the practice, you can do some of the sum using the Excel sheet. Like it gives a kind of prompt decision making. We will be so nothing much from my side. Only broadly you have to remember three formulas in the case of more than one sample. So one case is where the two different samples or two independent samples, where one case is it's a kind of unequal variance, and the second case is the similar variance. So that is the two cases in terms under the independent data, and for the dependent data you have only one single cases, and with the t-stats is in front of you, that is the, so with the practice it will come. I can understand. So just let me know in this week also whenever you need any assistance. I will be there. I can allocate time and I can go ahead with that. Now it's up to you. Like if you have any doubt in today's session, I'm here for another half an hour. You can ask. Please feel free to ask.
Okay, thank you, sir.
Thank you. It's your time now. So I'm closing the recording, but meanwhile, I will be here for another hour, half an hour to take your. So wait, let me stop the recording.